We are going to start now lecture 2 of chapter 7, class 11 mathematics, permutations and combinations. So in this lecture we will talk about certain results related to fundamental principles of counting, and we will solve certain problem based upon these principles. So first is fundamental principle of multiplication. So suppose we have two operations, and first operation it can be performed in m ways. We are saying the first operation it can be performed in m ways, and the second operation after this first operation has been performed, we are saying when this first operation has been performed, the second operation can be performed in the n ways. Then we are saying that these two operations that are happening in succession, they can be performed in m into n ways. So this thing will be more clear to you with this example. So suppose in a class there are 15 boys and 12 girls. The teacher wants to select one boy and one girl to represent the class for a function. In how many ways can teacher make the selection? So we are talking about there are two operations. First is to select a boy and then it is to select a girl. So to select a boy, the first operation we are talking about is to select a boy, and second operation we are saying it is to select a girl. Now there are total 15 boys, out of which one boy is to be selected. So number of ways in which this operation can be performed, it is 15, and the number of ways in which the girls can be selected, the number of girls we have, it is 12. So number of ways we can choose one girl out of these 12 girls, it is 12. So the total number of ways of selecting one boy and one girl, we have selected one boy, there are 15 ways. After that we are selecting 12 girls, so there are into 12. So total number of ways, we are saying by the fundamental principle of multiplication, we have the required number of ways of selecting one boy and one girl, it is 15 into 12, that is equal to 180. So this thing is explained over here. This is what the fundamental principle of multiplication is. Next we have is fundamental principle of addition. So now in this case we are saying that again there are two operations, and they are such that they can be performed independently in m and n ways respectively. Then either of the two operations can be performed in m plus n ways. So again we are talking about the same situation. We are saying in a class there are 16 boys and there are 9 girls. There are 16 boys and there are 9 girls. The teacher wants to select a boy or a girl as a class representative. Now teacher is not selecting one boy and a girl. We are saying either the teacher has to select one boy or teacher has to select one girl. In how many ways can the teacher make the selection? So number of ways in which one boy can be chosen, it is 16. Number of ways in which one girl can be chosen, it is 9. So we are saying that the number of ways in which either a boy or a girl is to be chosen, that is equal to 16 plus 9 is equal to 25. So in the previous case we are saying that we have to choose one boy and one girl. So the number of ways it was, first we have chosen the boys and then we have chosen the girl. What basically this thing represents is, suppose we are saying we have the boys B1, B2, B3, B4, so on up to B16, and the girls we have it is G1, G2, so on up to G9. Now what we can do, we are saying we have to choose one boy and one girl. We would have chosen boy 1, girl 1. We would have chosen boy 2, girl 1. We would have chosen boy 3, girl 1. We would have chosen boy 16 and girl 1. Similarly for the girl 2, There are total number of ways over here, it is 16, then it is again 16, and how many times we are adding it? 9 times. So we are saying the number of ways we have, it is 16 into 9. But when we are talking about this case, we are saying the total boys and girls we have, it is, we have boys, we have girls. The total number of boys and girls we are having, it is 25, and out of these 25 we have to select only one person. So that is why we are adding these terms over here and we are multiplying these terms over here. Next question we have is, in a cinema hall there are 3 entrance doors and 2 exit doors. In how many ways a person can enter the hall and then come out? So we are talking about the situation. Suppose these are the 3 entrance doors we are saying, and these are the 2 exit doors we are talking about. If a person enters through this door, he can come out of this door or he can come out of this door. If a person enters through the door 2, he can come out of any of these 2. If a person enters this door 3, he can come out of any of these 2. So the total number of ways we have for entering this door, it is 3. For choosing the entrance door, it is 3. The number of ways of choosing the exit door, it is 2. So the total number of ways we will have, it is 3 into 2 is equal to 6, and this is why the principle of fundamental principle of multiplication. And this thing is also clear over here, that how many ways we have, it is 1, 2, 3, 4, 5 and 6. These are the 6 ways we are talking about. Next is 3 persons enter a railway carriage where there are 5 vacant seats. In how many ways can they seat themselves? So 3 persons are there. These are the 3 persons we are saying, and the number of vacant seats we have, it is 5. We are saying the number of vacant seats we have, it is 5. So in how many ways they can sit? We are saying, suppose this first person, when this first person enters over here, how many ways he has to sit over here? Out of these 5 seats, he can choose any of these. We are saying out of 5 seats, he can choose any of these. So the number of ways is 5. Next is, if suppose this person, he sits at this point, this person enters and he sits at this point. Now how many seats are left? It is 1, 2, 3 and 4. Now when the second person enters, he is left with 4 seats. Either they are entering together or they are entering one after the other. We are saying that now when one person has occupied this seat, this second person is occupied with 4 seats. So we are saying out of 4 seats, there are 4 ways in which he can sit. He can sit at this seat, suppose. He sits at this seat. Now for the next person, for this third person, 3 options are there. Out of 3 seats, he can take any of these 3 seats. So how this process is occurring? It is occurring one after the other. So the total number of ways we are saying, it is 5 into 4 into 3, that is equal to 60 ways. Why 60 ways? How we can represent these? We are saying corresponding to this first person, it is 1, 2, 3, 4 and 5 options. Now suppose he sits on this seat, then for the second person we have 1, 2, 3 and 4 options. This is one case. Next case we are saying, suppose the first person sits on this seat, again he will have 4 options. Suppose the first person sits on this seat, he will have 4 options. So likewise we are saying he will have 5 into 4 options. So when the third person will enter over here, he will have 5. We are saying the total number of ways in which these persons can sit, it is 5 into 4 into 3, that is equal to 60. Next we have is, the flag of a newly formed forum is of the form, the flag is of this form, and it has, these are basically 3 blocks, and each of which is to be colored differently, and there are 6 colors to choose from. We are having 6 colors, 1, 2, 3, 4, 5 and 6 colors to choose from. So how many such designs are possible? So we are saying that to color this first block we are talking about, this block is to be colored. The options we have, it is any one of these 6 can be used to color this. We are saying any of these 6 can be used. So to color this one, it is, there are 6 options for the color. Next, if suppose one of these colors is used, suppose this color 1 is used, and we want to color this second box. So how many options we have? It is 1, 2, 3, 4 and 5 options. We have to choose out of these 5 colors. And next we have, if suppose this 2 is being used over here, we are saying to color this third box, the options we are left is 1, 2, 3 and 4 options. So we are saying the total number of ways we will have, it is 6 into 5 into 4, that is equal to 120. So we are saying that the required number of designs is 6 into 5 into 4 is equal to 120. Next is, there are 4 routes between Delhi and Patna. In how many different ways can a man go from Delhi to Patna and return if for returning any of the routes is taken? First case we are saying. So suppose we are talking about, this is the situation we are talking about, and the routes we have, there are 4 different routes. So this is Delhi and this is Patna we are saying. So first case we are talking about, if any of these routes is taken. So in this first case we are talking, in this first case, suppose when he is going from Delhi to Patna, how many ways he can choose these routes? It is 1, 2, 3 and 4. Any of these 4 routes he can take. And when returning back from Patna, he can choose any of these 4 ways. So the total number of ways we have, it is 16. Next is second case, we are saying the same route is taken. So in this second case, we are saying the number of ways in which he can go from Delhi to Patna, he can choose out of 4 ways. But when he comes back, in this second case, he has to take the same route. So he cannot choose out of any of these routes. Now the route will be fixed. So it means the options, he has only one option from the same route from which he has gone from Delhi to Patna, he has to take the same route. So the number of options he has, it is only 4. And the last case we have, it is the same route is not taken. So in this third case, we are saying when he is going from, Delhi to Patna, he can choose any of these ways, 1, 2, 3 or 4. He can choose any of these ways. Now suppose the route he has opted, suppose it is this route. Suppose it is this route he has opted. Now to come back from Patna, when he is coming back from Patna, the number of ways he can choose the route, it is 1, 2 and 3, because he cannot choose this first route now, because it is the same route is not to be taken for returning. So the number of options he has, it is 4 into 3 is equal to 12. So the number of options he has, it is 12. Next is, there are 6 multiple choice questions in an examination. Find the total number of ways of answering these questions if the first 3 questions have 5 choices each and the next 3 have 4 choices each. So there are 6 multiple choice questions, 1, 2, 3, 4, 5 and 6. The first 3 questions, these have 5 options. First 3 questions have 5 options. And the next 3 questions we are talking about, 4th, 5th and 6th question, they have 4 options each. These questions, they have 4 choices each. So we have to tell in how many ways these questions can be answered. So we are saying for the first question there are 5 ways, for the second 5 ways, for the third 5 ways, 4 ways, 4 ways and 4 ways. So when we multiply these values, we get it is 5 into 4, 20 into 20 into 20. So the answer we obtain, it is 8,000. So we are saying that there are total 8,000 ways to solve these questions. Next is, 4 flags of different color are given. in how many different signals can be generated if signal requires the use of two flags, one below the other. So the signal is to be formed. We are saying there are 4 flags we have, 1, 2, 3 and 4. So at the first place we can choose the flag out of these 4 options. Suppose we have chosen any of these flags. So for this second place we are left with this 1, 2 and 3 options. So we are saying, by fundamental principle of multiplication, we are saying that the required number of signals we have, it is 4 into 3, that is equal to 12. So there are total 12 ways to generate the signal with these 4 flags. Next is find the number of 4-letter words with or without meaning which can be formed out of the letters of, these letters are given to us, it is N, O, S and E, when the repetition of letters is not allowed. So suppose we are forming a word over here. So it is a 4-letter word. Now we have to keep one letter over here. So how many ways we can choose this letter? It can be N, it may be O, it may be S, it may be E. So there are 4 ways to choose this first letter. Suppose this first letter we have chosen. Now at this second place we are saying how many ways we have? It is 1, 2 and 3. Next at this third place we are saying we have, suppose O is chosen now, we have 1 and 2 ways. And for this last letter it will be over here, we are saying there is only 1 way. So the total number of ways we have, it is 4 into 3 into 2 into 1. You can write it is 4 factorial is equal to 24. This value is basically 4 factorial, it is 24. And the second case is the repetition of letters is allowed. We are saying now again we have 4 letters N, O, S and E. We have 4 places over here we want to place these letters and the repetition is allowed. We are saying we can place any one of these 4 in this. We can place any one of these 4 in this. We can place any one of these 4 in this. We can place any one of these 4 in this. So the total number of ways we have, it is 4 raised to the power 4, that is equal to 256. So we are saying there are total 256 4-letter words that can be formed if the repetition is allowed. Next is how many words with or without meaning of 3 distinct letters of the English alphabet are there. So the total number of alphabets in English, it is 26. And the letters we have to choose, it is given that there should be 3 distinct letters. And we are talking about 3-letter words. So for this first letter, the number of options we have, it is 26. When we are talking about this second letter, one of the letters is already chosen for the first place. So we are left with this 25 options. Now for this second place, one more letter is being chosen. So we are left with this 24 letters. And these 24 can be placed at this third place. The total number of ways we have, it is equal to 26 into 25 into 24, that is equal to 15600. So we are saying that these processes, these are happening one after the another. Next is how many numbers are there between 100 and 1000 in which all the digits are distinct. So we are talking about the 3 numbers over here, the 3-digit numbers we are talking about. These are the numbers lying between 100 and 1000. Now for the filling this first place, we are talking about for filling this first place, we have the options 1, 2, 3, 4, 5, 6, 7, 8 or 9. Because 0 cannot be filled over here. If we write 0 over here, it is not a 3-digit number. It will not form a 3-digit number. So we are not writing 0 over here. So the number of options we have, it is at this place, it is 9. Now at this second place, Suppose one of these numbers is already placed over here. For this second place, the options we have, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of these numbers, we are saying one of these digits is already used. So we are left with this 1, 2, 3, 4, 5, 6, 7, 8 and 9 digits again. Now, one of these digits, suppose 3 is kept over here. Suppose 3 is kept over here. So for the next place, we are talking about this last place. We have 1, 2, 3, 4, 5, 6, 7 and 8 digits. So the total number of ways we have, it is 9 into 9 into 8 is equal to 648. So the total number of ways we have, it is 648. Next is how many 9-digit numbers of different digits can be formed. So we are talking about now 9-digit number. Again, for this first place, we cannot place 0. So the number of options we have, it is numbers 1 to digit 1 to 9. Now one of these is already occupied. For the next place, the number of options we have, it is 0 to 9 and one digit is already occupied. So the number of options again we have, it is 9. Now out of these, one digit is being occupied over here, so we are left with this 8. Next, one digit is occupied over here, we are left with this 7. Next, one digit is occupied over here, we are left with this 6. One digit is more occupied, we are left with 5. One more digit is occupied, we are left with 4. One more digit is occupied, we are left with 3. And one more digit is occupied, we are left with this 2. So the total number of digits that we will have, we can form, it is 9 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2, and the answer we have, it is 3265920. So we are saying that these are the total number of ways in which 9-digit number, or these are the total 9-digit numbers that have different digits. Next is how many numbers between 2000 and 3000 can be formed from the digits 2, 3, 4, 5, 6 and 7 when repetition of digits is not allowed. So we are saying we have 4-digit number over here, and the numbers, they are between 2000 and 3000. So it means this first digit should be 2. So number of options for this, it is 1, and the repetition of digits is not allowed. So for this next place, we have to choose out of 3, 4, 5, 6 and 7. We have 5 options. For this next place, suppose one of these is chosen. For this next place, we are saying we have 4 options, and suppose one more is chosen over here. So for the next place, we have, it is 3 options. So we are saying we have, at this place we have 1 option. It is only the number 2 we are saying that can be at this place. So the answer we have, it is 1 into 5 into 4 into 3. It is equal to 60. So we are saying by the fundamental principle of multiplication, the total number of required ways, it is 60. Next is how many 3-digit odd numbers can be formed by using the digits this. First case is when the repetition of digit is not allowed, and second is when the repetition is allowed. So we have 1, 2, 3, 4, 5, 6 and we require 3-digit odd numbers. So we are saying there are these options over here. So first we are saying that the repetition of digits is not allowed. So we start with this last place. We require the number to be odd. So out of this 1, 3 and 5, we have the options 1, 3 and 5. So we have 3 options over here. Only then the number will be odd. If one of these numbers is occupied at this place, then for this place we have the options 2, we are saying 1, 2, 4, 5 and 6. So number of options we have it is 5. Suppose one of the numbers, any of these numbers is occupied at this place, and the options we are left for this first place it is 4. So the total number of ways we have it is 4 into 5 into 3, that is equal to 60. In the second case, we are being asked the repetition of digits is allowed. Again we are talking about 3 numbers over here. This is option 1, 3 and 5. So any one of these 3 can be kept at this place. Now repetition is allowed. Total of number of digits we have it is 6. So this place, at this place we can choose any one of these 6 numbers. For this next place we are saying we can choose any one of these 6 numbers. So the answer we have it is 6 into 6 into 3, it is equal to 108. The answer we obtain it is equal to 108. Next is, how many odd numbers less than 1000 can be formed by using 0, 2, 5 and 7 when the repetition of digits is allowed. This is important, when the repetition of digits is allowed. So we are saying that we basically require 1 digit. We are saying the number should be less than 1000. It means we are talking either the number can be a 1 digit number, it can be a 2 digit number, or it can be a 3 digit number. Now suppose we are talking about the first case, that it is a 1 digit number, and the condition given to us is that it is an odd number. So out of these digits, the 1 digit number which is odd, we are saying it can be 5 or 7. So number of 1 digit numbers it is 2. When we are talking about 2 digit numbers, the number is to be odd. The number at this place, it can be 5 or 7. There are 2 options. The number at this place, it cannot be 0, otherwise it will become 1 digit number. So we will have 3 options because repetition is allowed. So it can be 2, 5 or 7. So we are saying there are 3 options. So the total ways we have it is equal to 6. And the 3 digit numbers when we are talking about, for this last unit place we are saying the options we have it is 5 or 7, so it is 2. And for both these, for this first place the options we have it is 3 options. It can be 2, 5 or 7, it cannot be 0. And for this place we are saying the options we have it is 0, 2, 5 or 7. Number of options we have it is 4. So the total number of ways we have it is 3 into 4 into 2, that is equal to 24. So the total number of digits that we will have, it is 2 plus 6 plus 24. The answer we obtain it is equal to 32. So we are saying the total number of required type of numbers, it is 2 plus 6 plus 4 plus 24, that is equal to 32. Next is, how many numbers are there between 100 and 1000 such that 7 is in the units place. So we require the numbers in the form, we are saying the number should be between 100 and 1000. So we are talking about 3 digits over here, and at the unit place it should be 7. So the number of options for this tens place we have, it can have number 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. Any of these numbers can be there. So the total number of options we have over here it is 1. The total number of options we have over here it is 10. And at the units place, when we are talking about the unit place over here, the numbers we can have it is 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 cannot be there because otherwise it will become a 2 digit number, it will become less than 100. So the options we have over here it is 9. So the total number of ways we have it is 9 into 10 into 1, that is equal to 90. These are the total number of ways, required number of ways. Next is how many numbers are there between 100 and 1000 such that at least one of their digit is 7. So we are saying at least one of their digit is 7. So first case we are considering, suppose 7 is at the units place. We have one option over here. At this place we can have any of the 10 digits 0 to 9. At this place we have any of these digits. So the numbers we can have, it is 90 different numbers can be there. Next we are saying again 3 digit number is there. Suppose the 7 is at the 10th place. So at this place, we are talking about this place, the number of options we have, it is 10. At this place the number of options we have, it is 1, and at this place the number of options we have, it is 9. So the total number of options we have, it is 90. Then we are saying the 7 is at the units place, at the hundreds place. This place it is 7 is there. For both these we have 10 options. The answer we have, it is 100. The total number of digits we have, it is the total numbers we have, it is different numbers we have, it is 100. So we see that the total number of required numbers that we have, it is 90 when it is at the unit place, then 90 when it is at the hundreds place, and then 100 when it is at the this is at the unit place, tens place, and hundredth place. So answer we have, it is 280. So these are the total number of numbers that we can form. Next is how many numbers are between 100 and 1000 which have exactly one of their digits as 7. So we are talking about 3 cases over here. We have exactly one place is to be 7. So suppose 7 is at the units place. Second case we have 7 is at the tens place, and last we are saying 7 is at the hundreds place. So in this first case we have one option for this term. We have now at this term we can have 0, 1, 2, 3, 4, 5, 6, 7 is already occupied at one's place. So we will have the option, it is 6, 8 and 9. So the number of options we have, it is 9. And at this hundreds place we are saying the total options we have, it is out of these options 0 cannot be there. Out of these options 0 cannot be there. So number of options we have, it is 8. So the answer we are getting, it is equal to 8 into 9, that is equal to 72. In the second case 7 is over here, so we have only one option at this place. At this place we can have options 0, 1, 2, 3, 4, 5, 6, 8 and 9. So the total number of options we have, it is 9. Now suppose one of these is filled at this place. So the options for this first or the 100th place we are talking about, the options for this digit we are saying we have 1, 2, 3, 4, 5, 6, 8 and 9. 0 cannot be there. 0 cannot be there. So the total number of options we have, it is 8 again. So the total number of options we have, it is 72. It is 8 into 9, it is 72. Now in this last case we are saying at this place it is 7. So number of options we have, it is 1. Next at this place we can keep 0, 1, 2, 3, 4, 5, 6, 8 and 9. So the number of options we have, it is 9. At this last place also the number of options we have, it is 9. So the total number of options we have, it is 81. So we are saying that the total number required, the total number of required numbers, it is equal to those which have 7 at the units place, those which have 7 as the tens place, and those which have 7 at the hundredth place. Sum of all these values, it comes out to be 2, 2 and 5. So this is the required answer. Next is how many numbers are there between 100 and 1000 such that every digit is either 2 or 9. So we are talking about the 3-digit number. At this place we can keep 2 or 9. At this place we can keep 2 or 9. At this place we can keep 2 or 9. So we are having 2 options at this place, 2 options at this place, and 2 options at this place. So the total number of options we have, it is equal to 8. So we are saying the required numbers of numbers, it is 8. In this case the answer is 8. Next is how many 3-digit numbers can be formed without using the digits. This we are not going to use the digits. So the digits we are left with is 1, 7, 8 and 9. We want to form 3-digit numbers. For this first place we can place any one of these 4 numbers. On this second place we can place any one of these 4 numbers. On this third place we can place any one of these 4 numbers. The total number of ways we have, it is 4 into 4 into 4, that is equal to 64. This is the total number of required numbers. The number of required numbers, it is 64. Next is find the number of positive integers from 1 to 1000 which are divisible by at least 2, 3 or 5. So first case we are saying the number of integers which are divisible by 2. This notation we are using AK when we are saying it is the set of positive integers from 1 to 1000 which are divisible by the number k. This AK means this thing. So when we are talking about NA2, it means number of elements in the set of elements which are numbers from 1 to 1000 which are divisible by 2. So the number of elements over here, it is greatest integer of 1000 by 2, that is equal to 500. Number of elements in A3, those which are divisible by 3, it is greatest integer of 1000 by 3, that is equal to 333. And number of elements in A5, those which are divisible by 5 from 1 to 1000, it is 1000 by 5, that is equal to 200. Next we are saying those numbers which are divisible by 2 and 3, that will be equal to 1000 divided by 6, greatest integer, the answer we have, it is 166. Those number which are divided by 2 and 5, so it is equal to 1000 by 10, greatest integer, the answer we get, it is equal to 100. Number of elements A3 intersection A5, that is equal to 1000 divided by 15, greatest integer, and the value we have, it is equal to 66. And the last we are saying it is number of elements which are divisible by 2, 3 and 5. So that will be equal to 1000 divided by 30, greatest integer, the answer we have, it is equal to 33. Now the formula we are going to use over here, we require number of elements which are divisible by at least one of these. So it is an A2 union A3 union A5, this thing we have to calculate. And the formula we know from the set theory that it is number of elements in A2 plus number of elements in A3 plus number of elements in A5 minus number of elements in A2 intersection A3, the sum of these 3 terms, and last plus number of elements in A2 intersection A3 A5. We are talking about the sum of first 3 we are saying, the sum of first 3 we are saying it is over here. The sum of next 3 we have, the sum of these 3, the next 3 we are talking about. We have to subtract the value over here, and the sum, this last value we are adding over here. So the final answer we obtain, it is 500 plus 33 plus 200, 500 plus 333 plus 200 minus 166 minus 100 minus 66 and plus 33. This value we are talking about. The last value we are saying it is plus 33. So the final answer we obtain, it is 734. So we are saying the number of the positive integers from 1 to 1000 which are divisible by at least 2, 3 or 5, it is 734.